Hello and good evening, everyone. Welcome to this another episode of a webinar on data science hosted by Team Career Era. I hope I'm audible to everybody.
Yep, we can hear you.
Great.
Okay.
So the topic for today is data science storytelling using visualizations. Now, our guest speaker for today is Mr. Darren Laforgue. He's the Chief Executive Officer at LEM Solution Limited. Now, Darren holds a master's degree in physics from the Imperial College of Science, London, and started his career as a satellite engineer. Now he has built a credit derivative trading platform for the trading desk, which ran over for a decade, traded over $250 billion derivatives contracts, credit default, swaps, bonds, and interest rate swaps alongside with other financial products. Now, Darren is now involved with machine learning, artificial intelligence, and big data for the purpose of trading and decision making, which he has a huge passion for, now where it solves for business need. So without further ado, I'll get this mic on to Darren. Sir, the stage is all yours.
Okay, I think I'm here. Right, and I shall share my screen. Share. Can you all see that?
Yes, visible.
Good. Okay. So thank you for the kind introduction, as usual. Introductions are always quite kind. I think there's about 3 or 4 masterclasses that I'm going to that I've been asked to do, and it's kind of like asked to pick out some of the titles that I found interesting out of the several titles that were available. And one of them was storytelling using visualizations. So I went through and I'll tick this one, and tick this one. But actually, in a way, the using visualizations kind of like stands out quite a bit from the other talks in the sense that it's just very relevant. And I never thought of it as a topic before, but it pretty much is quite an important topic. And I went through the breakdown of it, and we will go through that. And it just there's basically a lot of relevance, and we use a lot of techniques that sometimes we just don't know are even available to us. So we'll be going through quite a lot of the life cycle of that, and we'll see how it manifests itself, at least. So who am I again? I'm Darren. I did a master's degree in physics at Imperial College London quite a while ago now, a quarter of a century ago. I started my career industry in satellite engineering, so I was designing satellites. And then I quickly moved over to the area of quantitative finance for the purpose of trading. And whilst all of these two roles seem very dissimilar, which they are in many capacities, there's also a lot of skill overlap between the two. And actually, there's a whole bunch of other different industries as well. That's sort of like, although the industries appear to be very different, the skill sets and the types of techniques that you tend to use there'll be quite large overlaps between them. So my contact details are here. You can get me on LinkedIn. So I'm just Darren Lefko. I think I'm the only one, which makes me quite easy to find. I'm also there's my email address for what it's worth. And also Twitter, with the Twitter handle that I added before, just at the end. So it's just at @dlefko, if you did want to follow for whatever reason. And then there's this class link, which you should all have anyway because you've got. But I thought I'd stick it in there. It's quite a long one, but that's a link to this particular class. And then I think finally in the introductory bits, there's a couple of publications. I did write a book on Python programming. It's called Top of the Stack, and it's kind of like how to get yourself to the top of Stack Overflow. It's all about coding effectively. And actually some of the techniques and things that I will be talking about today, some of them are actually in the book. And then there's another book that's on Amazon. It's called Stand Behind Me, and it's the life cycle of a quantitative trader. And it's more actually about the life cycle of a trader rather than the technicalities, although it goes into that a little bit. So that's a little bit of background and connectivity and so forth from my part. Today's presentation, I'm told it's 2 hours long, so it's 120 minutes. Be about 90 minutes of talking and about 30 minutes of questions. I usually overrun, but this time I'm going to attempt to not overrun. So I've reduced the number of slides on purpose to not overrun. There's about 75 slides, but I think we've been through half a dozen of them already. So we're finding that in that space, we're moving on swiftly. It's about a minute and a half a slide or something for the purpose of talking. And finally, the overview of what we're going to be covering, or at least what I was asked to cover in the talk itself. So we're going to look at the 4 following points, which is an in-depth look at how to use data visualizations. Then we're going to look at another section, which is best practices. And then we're going to move on after that towards the importance of data cleaning, which is quite an important section in itself, and we'll have time to discuss that. And then finally, telling stories with your data, because ultimately that's the whole purpose of everything that we're trying to achieve, is going through the process, picking what we need to, making sure that our data is accurate and kind of like telling the right picture. And then finally putting that out there to the world in some way, and remembering that, and we'll get to this point much later on, but the audience is can be very different, and you have to sort of like know who you're delivering to. So, and just something, actually, I don't know if any of you did watch a previous video that was done by myself, so a previous presentation. I just stumbled across this and actually thought I'd add it to the last presentation, but it's probably actually more applicable here than in the previous presentation, because this book was written in 1941 and actually circled the same part of this as well. But at the bottom of the book, like if you could read it, but I just wrote it out there, the person, the author of the book, is quite proud that they created 124 illustrations. And that was obviously, back in the day, a big thing. All they had was paper and kind of like, the black and white transmission of information, and not much else. And they didn't have the drawing tools and the graphical packages and all the rest that they could do. And it was a big deal to kind of like put something out. You really do have to put your mind back quite a long time, because 1941 was way before my time. Even it was before computers. It was a harder thing to do, and even in this quite brief presentation that I'm giving now, there's probably 124 illustrations that are far better than the 124 illustrations that were provided in this book all that time ago. So kind of like we do stand on the shoulders of giants in terms of the achievements that we've got, and the technology that's available to us. And that's quite a large part of what this particular talk is about. It's sort of like just, how can we use the tools that are available, or how should we use the tools that are available, and what is available to hand, and what we can do with them. So we move on. This is broken into 4 parts, so I've literally split it into 4 parts. So this particular webinar is going to provide an in-depth look as to how to use data visualizations to create compelling and informative stories. So that's going to form part 1. Part 2 of the description is we're going to cover the best practices for selecting the right type of visualization to communicate your message, and how to interpret that data. And then after we've interpreted that data, how to create useful, insightful graphs, so that we can put this information to our audience, whoever that audience might be. And we'll talk about the audience as well as part of an integral part of that. The third component of the talk is we're also going to discuss the importance of data cleaning. That's going to be tremendously important, and preparation for effective data visualizations, and then how to create meaningful narratives. So how to get this on paper, in a display, in a way that's going to be useful to the end user. And the end user might just be yourself. The end user might be a classroom full of children, or it might be, half of the, global community on the internet. But one way or another, we want to get our meaningful messages and narratives across. And hopefully by the end of this webinar, you'll be able to confidently create visualizations, although we're not going into any technicalities. So it's more like an overview and understanding of it for the purpose of this webinar, and then be able to use them to effectively tell the different variants of the stories that we want to tell with our data. But it's much more than just telling stories. It's more about actually getting true data and information out of the extracting the useful information out of the plethora of information that we have, and ultimately making data-driven decisions. So when we say stories, we're not making up fiction. This is kind of like factual information that we're going to attempt to interpret in the most unbiased way possible, and present that to ourselves. So the first thing to ask is, for the purpose of data visualizations, is what are they? And for the most part, it's graphical representations of data and information. We want to make complex data sets more easily understandable, and that's the whole purpose of the visualizations. What we don't want to do is take data and make it even more confusing. So we're going to take this and put it into some kind of format that's going to help us in some way. And with this, we want to be able to communicate our key insights and our findings. So we want to be able to show things like the outliers or observations or clear patterns and trends that our unbiased and true source of data shows us. And we'll be looking at that component of it as well. So data visualizations, just a couple of very simple examples to start with, but in a way, especially the top three, the bar charts, the line charts, and the scatter plots. But you'll also see a heat map as well, because I just felt I'd throw something else in there just to start with. They're very, very common. We're going to come across a whole bunch of visualizations in this talk, probably about 50% of which you may not have heard of. But we'd have done a lot of the bar charts and line charts and scatter plots, where, you know, from the ages of 10 to 15, you kind of like done a lot of that kind of stuff at like, if you were in England at GCSE level, or whichever country you're applicable to, you'd have learned that early in life. And the reason for that is that these types of plots quite easily show us data without having to do too much work, and they're just very handy and very useful. So they're nearly like the ABC of graphing in some way. So we do tend to use them a lot, and there's nothing wrong with that, although we'll see like many more complicated types of charts in the talk as we go along. These are kind of like the fundamentals, and maybe even in many cases like what you might call the go-to, and they're certainly much easier to produce, especially when you're like working with you know, languages and packages and so forth. So something like Python, plotting bar charts and line charts and scatter plots are sort of like well advertised and well documented as how to perform that. And other applications that are simpler than programming languages like Excel spreadsheets and so forth, they come out of the box as well. So we move on just to a couple of, you know, these examples, and I've pulled a lot of these pictures off the web. They're not things that I've created. I guess I could have created them and maybe done a better job of creating them in some cases, but there's literally hundreds and hundreds of examples to pick out of the web. I draw your attention first of all to the top left-hand corner one, which is the bar chart, which basically we can see how simple it is and how easy it purveys its data. It relates to categorical data in this particular case. We can draw conclusions very quickly. For example, it's a classroom full of children in this particular case, and they've asked to pick their favorite color. And the most favorite color, quite quickly by observation, is yellow. We didn't have to do any work for that. And the least favorite color is green. We could make a further inference out of that chart, just like broadly speaking, which is a total number of children in the class, like just at a guess, and I don't know this for sure, but if I see that there's 5 categories across, and on average about 6 children per category, that means that there was 30 children in the class, and that kind of like tells us a lot about the information that we had. It was a small set of data in that particular case, but we're able to extract something very quick. And this is something that we get quite early on, and it's very simplistic. We go to the other top chart, which is the temperature, which is a line chart. It's just a typical line chart, very common again. Quite a lot of the time, a line chart might be used on the x-axis, which is the independent variable. You'll quite often see things like dates and times, and it's used to plot how something progresses over that period, of time. And in this case, it was the temperature on a random September. And we see how the temperature performs during the course of the day. And this chart, again, is just an example of something that does a job very simply, doesn't take much effort at all, and completely transmits all the information that's needed to be transmitted without kind of like complicating anything. Then we look at the bottom left-hand corner of the chart, with the bottom left-hand corner one, which is a scatter plot. I on purpose didn't get one that had a best fit line in. There was plenty of best fit lines. So this is just literally the scattered plots. And we see that there's not much data there, but kind of like hopefully you can sort of like visualize in your mind that if you did plot a best fit line, which is a line that gets as close as possible to all of the dots, that we you would plot some upwards sloping line. And that would be telling us some kind of relationship between the weight and the height of the people in this set of data. I don't know where this data was from, so it's more like descriptive, but that might be logical, as in people who are generally taller in height we might expect some kind of positive correlation, and for them to weigh more, and we can use this chart and visualization first of all to capture that, to capture some kind of correlation. Are these points dispersed? Are they inversely related? And how close are they together? So those types of things, and the scatter plot lends itself quite well to that sort of data. And finally, on the bottom left, my bottom right hand corner, I'm hoping it's your bottom right hand corner as well, is something called a heat chart. It comes under other names as well. We'll see one or two other names for it. But there, I believe that was just the, because you can't see the actual writing on it, but it's the S&P 500 on a particular given day. And this chart, like, where is it useful for? It's not heat in this particular case. It's the performance of share prices, and if the shares have gone up in price, and this is very typical in the financial world, if shares have gone up in price, you'll get kind of like a green and a brighter green for the ones that have gone up more, and if they've gone down in price, you'll get reds. So this particular day has more reds and greens. But also at this point in time, this chart provides you one extra piece of information that you may or may not be aware of, but the actual size of the chart represents the market capital. So they're showing you that this chart is actually showing you an extra dimension of information without kind of like having done anything in 3 dimensions or plotted like a second chart or a third chart to show that. So there was a hidden piece of information that came free in this chart as well. So and it would be a better chart to use, like if you're doing this, than a bar chart, or line charts or any of the other ones, although you could choose to use the other ones, and sometimes in some cases you will, like you might use a scatter plot to find the outliers for the day. So we move on with data visualizations. And what do? They allow us to explore the data and find patterns and trends. And in particular for visualizations, as opposed to algorithms, and I tend to work more on algorithms and visualizations, but the visualizations are there for us as the humans. And when we get this picture, if it is displayed in the right way, we're able to draw our conclusions quite quickly in a very useful way. And there's different ways that this comes about. We get 2-dimensional information, and for the most part, this particular talk will focus on like 2-dimensional charts, but that certainly doesn't detract from 3-dimensional charts. They're very much used for a whole variety of things, apart from the fact that we do live in a 3-dimensional world, so it's important to have that type of data. But then moving on from 3-dimensional charts, we've got interactivity. So there's other techniques that we've got available to us, like as data scientists or for the purpose of visualizations, that just never existed like 20 to 30 years ago. And whilst we could, possibly draw some fundamental 3D charts, we wouldn't have been able to do the interactivity in the same way that we can do today. We've got the internet, we've got video visualizations, you've got point and click, so you can sort of like drill down from one chart into another one and have dynamic charts, or when you move your mouse around the screen, like certain things highlight themselves and pop out. So there's other things as well, although we are going to focus for the most part on 2D charts and a few 3D charts for the purpose of the talk. But again, it's going to more than enough to cover our time. So there's plenty in there and plenty of stuff that we'll be able to see on that. So we do take a look at 3D charts, and I start with the top right, the top left-hand corner one, which is the bar chart. And unlike the bar chart that we saw 2 slides ago, this one has 3-dimensional data, and it actually offers you an extra piece of data or an extra dimension that the other chart didn't do. And if you were to try to do this 3D bar chart on a, by displaying it in 2D bars, you'd have to take the slices, and you would need 4 representations, 4 flat slices in each case for the cases, and you could sort of like put them side by side and do your representation that way. But the reality is that this bar chart lends itself much better to a 3-dimensional visualization, where, and you can't read the axis there, but it's seasons on the depth axis and time period on the y-axis, which is the 2 flat axes that form the bottom, and the z-axis which is the one going upwards, which is the colorization one, and it's also got a color bar chart on the side of it. That represents temperature, and we can see how temperature changes according to season, and the red one is for represent our summer periods, and the little blue one's going to represent our winter periods. And one advantage with a 3D chart is that you could do a rotation of it. You could sort of like move it around, or the user that's inspecting it, they might have the ability to move it around. But it's given us a lot more information than a 2D bar chart has. And likewise, if we go to the other top one, we've got this surface chart, and you might draw an analogy between a surface chart in 3-dimensional space compared to a line chart in 2-dimensional space, and say, like, where is this useful? And I do remember back in the day, and I'm going back quite a long time, but back at university, one of the things that I had to do with a colleague was we had to fire a laser at a CCD array, and we sort of like wanted to get the light intensity that was incumbent on the CCD array, which is just the same array that's doing the taking my video right now, and it's sort of like looking at me, and it's got a certain number of pixels across and above, and we can measure something called the centroid of the laser, where most of the light was going in, and then we could see the dispersion of it, and from that you could measure relative movement in the X and Y plane. So that was quite useful information, and in order to show this, it was you could only really show that you could show it with a 2-dimensional plot, but it would be deficient. Then moving down to the bottom 2 charts, we see the same bar chart underneath the top bar chart, and I've written 2D going to 3D, and the reality is that's a nice looking chart, but the reality is it hasn't passed us any more information. So it goes very well into a presentation, but for informational, because it looks quite nice and shiny, but for informational purposes, it hasn't given us anything particularly extra, other than it looks nice. We could have drawn the upward arrow anyway. It's a sort of like global non-quantitative arrow, and we could have plotted our points out much better. And arguably even, we haven't got any axis on this particular chart, so it's just visually telling us a global picture of a story. And the same is true for the business infographic on the bottom right-hand corner, which is a pie chart. We will look at pie charts as well. This adds no extra information on a standard flat pie chart, other than, again, it looks nice in the presentation, but that doesn't stop you using it. In fact, in many cases, you do want to use these types of things because it fits with the narrative and the presentation that you're trying to give. For business purposes, you want a shiny, nice looking 3D type of looking chart compared to a bog standard flat chart. But if you were doing the same thing for a scientific publication, you would go for a flat chart that's probably better described. But that's that. So we move on from there. For the purpose of data visualizations, the next question to ask is who uses them? And they're often used in fields such as business, finance and statistics, but the reality is and I did have this in the last presentation, and I actually did list them, quite a few. There's a whole ton. In fact, every single industry that you can think of uses data visualizations in some way, whether it's healthcare, engineering, politics. I could pick a whole bunch, like travel industry, a whole bunch of other ones. And the reality is from the number of people just on this course on their own, you might be able to think of like several examples in your own industry that I haven't listed out here that are massively applicable for data visualizations and how we do it. So the reality is all of these tools, they will manifest themselves, and they do manifest themselves in all of the industries. And the only difference is you might tend to use a certain set of some types of charts more frequently in some industries than you will in another industry. But ultimately, and maybe aside from politics, ultimately they're all used to make data-driven decisions in some way or form. Why did I leave out politics? Because politics is kind of like an exceptional case, because the reality is in the real cases, we do want to show the true data and make our political decisions based on like true well-informed portions of data. So for example, like, have we truly measured global warming, and is that a problem, and do we want to centralize our politics around kind of like global warming statistics? Or does the Conservative Party in the UK or the Republican Party in the United States kind of like want to paint a picture of their narrative and then omit some data and put some bias in there, so you don't get those same biases that fall into like engineering types of problems or healthcare types of problems, because you just literally want to isolate and fix, where you can use visualizations to skew information in some way. We're going to attempt in all parts to not skew information and just to draw as best conclusions as we can. And actually, as part of that, realize that we come with inherent biases and do our best job to strip out our inherent biases for the purpose of visualizations. And that's a difficult task, because wherever we are, we still have these biases, and we'll come across that later in the presentation. And here's some examples just of charts that are in fields and on purpose for the business one. I could have done a whole bunch of graphs and charts and displays and visualizations that you're used to seeing, but I thought I'll put in one that's a hierarchy type of chart. They come under different names again. It could be called an anagram and other things as well, but it talks about hierarchical relationships, and that is a chart, and that is descriptive information, and it's best put in this type of format and published out that way, rather than having a table of data, because it might not be visually as interpretable. Straight away from this type of thing, you might be able to see like who's the CFO, or the CEO of a company, or who's the lead engineer in a team, or who's a manager of a football team, and who the players are, and so forth. Then we move on to the middle one, which is the financial chart. And again, I just tried to pick something that's really, really different from everything else. And this particular chart is the price of Bitcoin versus pound sterling. And this chart tells us quite a bit. Just by like, if you were able to read it, and if you do understand what the chart is telling you, the reds are telling you the days that things have dropped, but you could kind of like say, well, I already knew that. Although like it on the horizontal parts, it's much easier to pick it out, the reds from the greens. And then you have open, high, low, and closes. So this is called a candlestick chart. And every now and again, you can see a really thin spike, and that's something to do with the intraday volatility that's there. So this chart captures a big picture and attempts to capture a smaller picture at the same point in time. This is quite useful for finance. And underneath, there's another chart underneath the line chart, and so we've got a bar chart and a line chart combined in this particular case, and that tells you something about the volume on a day. And one thing that we do see is that on a day where the prices moved considerably, the volume is much higher, and that's a lot of people executing transactions. But that's not always the case, although that's sometimes globally the rule. And finally, we move over to statistics, and that's for descriptive information. And I'm going to go into this a bit more in other slides, but just what we can see from there. And this is just something I picked up from there, and I try to keep it as broad-based as possible. This is a box plot or a box and whiskers plot. It's quite simplistic, but we can put things into categories in this particular case. And we can draw straight out of this our obvious or our key sort of like things that we tend to look for, which is like the mean and the mode, the most frequently occurring thing, or the average. And then we can sort of like look for our maximums and minimums, and then we can look for something like a dispersion type of measure, which is like an interquartile range, or maybe standard deviations if we were a bit more sophisticated. But nonetheless, that describes a whole bunch of data for us, quite very, very well, in fact, and quite simplistically, which is quite nice. So we've given ourselves this data, and again, like just on that chart, like the third bar across the gamma one, we can see that it's just got a wider dispersion, but pretty much the same average as other ones. So there's more volatility in that data set than there was in the other data sets, and that data set could be anything. It could be applicable to any industry and any type of measure that we have. So we move on, and this is where I am going to go into a whole bunch of different things. But from each of these examples that I do kind of like pull out here, I'm just going to pull a few examples for the visual purpose so that we can get through the presentation, because otherwise we just spend 2 hours looking at pictures of varieties of different charts that we can have. But I'll just talk briefly through them, or just mention some names. But we've got the obvious pie chart, we've got maps, so we'll look at a map here and there. Flow diagrams, network diagrams. We've got something called a tree map, which isn't a tree map, which isn't a tree. It's more like a heat map. Then we've got heat maps. We saw something before that looked like a heat map. And then something that you may or may not have come across, which is word clouds, which is quite nice. And then Gantt charts. So I'm going to pull a couple of these out, and just for the purpose of diversity and showing what some of them are. I can't show what all of them are in this presentation. But we have on the left hand side, and again, I try to steer away from just doing our plain standard charting things, but because these things are also applicable, and I've just written a Python dictionary underneath it just to like remind myself of something. But like this is a visual representation of something that might, for example, go into a piece of code or logic gate, and you can take this kind of like semi-structured data and have a workflow that goes through it. And if I was to give anyone like this piece of code, and say, for example, Python or JavaScript or something else, and said like, is the lamp plugged in? And then, if it's plugged in, then it's a yes, and then go and do the next thing. And if not, and then sort of like go around with the logic in terms of the code. Someone who's used to reading the code, well, they're fine with that. But the majority of people who aren't used to reading the code are going to go like, oh, right, I have to like now sit down for 10 minutes and figure out what it is. Whereas given this picture, it's kind of like blatantly apparent. And this is effectively the way that children might first start to learn, because if you plunked 30 lines of code in front of them with if statements and so forth, they just walk away disinterested and confused. Whereas this picture's quite simplistic. And it's also simplistic, actually, like, if you have instructions and so forth, again, you might not want to read the wording of the instructions. This visualization is very descriptive. It tells us everything that we need to know in one simple picture. A picture paints 1,000 words. Then we move on to the next one. This is called a tree map. Your standard tree map is actually like, squares, but I thought I'm going to show something else. I'm going to I'll pick the few circle examples out of the tree map thing, just to show that it doesn't have to come in a square format. It's circular categorical data. And again, this this goes into a whole variety of different industries. You can certainly use this technique in a whole bunch of places. For the purpose of like the finance industry, it's if you're like looking kind of like at share prices, the inner core might be like your 4 or 5 major markets, and then inside those major markets, like the continents, it might be the US, Europe, and Asia, the Middle East. You can sort of like drill down into the exchanges that exist in that, and that will be the next level out. And then finally, you could sort of like drill into within the exchanges, like the FTSE 100 has 100 components, and the S&P 500 has 500, and that's in the US. So you can sort of like drill in and out and see how the entire ecosystem is moving, and it's very, very informative. If like the entire world is kind of like in financial decline, you see all of these as being red, so the colors telling us something as well. So we've got multi dimensions, all in the space of a 2-dimensional flat screen. So we've been able to present this information relatively cheaply, because the reality is a flat screen delivered on on an internet web page is quite simple to show. We can do this relatively, and we can make this interactive as well, this type of chart, and you can sort of like do the drilling in and so forth. And finally, like I definitely wanted to throw this one in, which is word clouds. It's something that we've heard of the term, and some of you may be used to it and some may not, but it's not just it's not actually just advertising. What it is if you were to, and this has come about in the last few years, like since social media was created. But if you were to kind of like scrape Twitter or Facebook, and like in this particular case it says knowledge and education. If you were to scrape Twitter, amongst a whole bunch of school users, and look for keywords and kind of like make the ones that were the most commonly occurring ones, make them bigger, and the ones that were least commonly occurring, so the size is proportional to the count. And also maybe even making the colorization another type of category, or like a geographic category or something like that. So you can display you can quite well display language categorical data very well with things like word clouds. And again, I've seen even like visual moving versions of that, where you sort of like move around into different spaces, and different keywords become large within that space. I mean, you can see the things around it. So that's a very useful type of chart as well. And then we go on to additional examples 01, because I couldn't think of anything else of how to fit so many types of charts onto our into the presentation without squeezing like 30 of them all into one screen. And the first one in this example is Sparklines, and that's quite often used in finance. And I think one of the slides actually has Sparklines, so I'll go into it at some point. Then you've got bullet graphs, dendrograms, Sankey diagrams, box plots, which is kind of like similar to the like box and whisker plot in a way, chord diagrams, Pareto charts, and radar charts. We'll look at a radar chart. And again, like some of these you will have come across, others you might have to Google what are they, but when you do Google them, they're things that you have seen before. You just didn't know what the terminology was for them. And there's a way of creating them that's relatively logical and simple. So we go into our more chart examples, and the first one I pick out is Sparklines. One place that they're used is finance, but they're also used in engineering. You'll notice something about the Sparkline, which it doesn't have any y-axis description or x-axis. It doesn't have anything at all in that capacity. It literally just shows up and down kind of like moves, and that's kind of like if you just wanted to have a very simplistic view of how a whole bunch of stocks have moved, and stick it all into a spreadsheet or onto a web page quite quickly, so it's visually easy to see. You might color up moves and down moves, and that's sort of like the most you would do. You haven't labeled anything, there's no percentages or anything. You'll use Sparklines, and you might use the same thing in engineering as well for similar types of things, where it just needs to go on the dashboard, and you haven't got room for all of the numbers. You just want some sort of visual thing. And A sparkline doesn't have to be a line. You could do the same type of thing with a bunch of bars. The middle one, I just put it under the stats category, but the reality is, again, it fits into a humongous amount of industry data types for the purpose of visualization. We won't necessarily show these things as box plots, but you know, we might display them in different ways. But I wanted to put this on because it has some key parameters in here, which is straight away you've got minimums and maximums. So you're kind of like bounding your data in some way. And then you've got like a lower quartile, which is the blue one, and an upper quartile. Again, I mentioned you know, standard deviations, but this is much more simplistic in its computation. And you've got something between the quartiles called the interquartile range, which contains ultimately the bulk of the data, rather than the outliers, which are the max and the min. And then you'll have something like the median or the mode that goes somewhere in the middle, which is your averaging. And that's descriptive enough for like a whole bunch of data. You know, whether it's measuring, you know, the heights of all of the people in the country and sort of like, you know, plotting the distribution, and, you know, who's extremely tall and who's extremely short, and what's the average height, or life expectancies and so forth. And again, you know, if you were doing life expectancies and so forth, well, obviously your minimum might be close to 0 for like hot deaths, and your maximum at some point will be the oldest man in the world. But most people will live around the medium, and you've got like these expected plots that go along with it. And finally, just for the purpose of being very different, I picked out a radar chart, and it's got nothing to do with radars. It's actually quite good for scoring categorical data. And when I first looked at some of these charts and I didn't really understand what they were doing, they're actually really, really useful. Although I don't use them myself, I have seen them used sometimes in finance, but actually it lends itself much better to, you know, this particular case was certain categories of scoring for the purpose of gymnastics. And the better that you are at any one ability, the further that you go out towards the outer bound of that chart. And in order to pick kind of like the best gymnast, you would look for something with the largest area. So like their technique for landing, and their technique for style, and so forth. So without reading the wording on the charts, we can sort of like get an inference of what they're straight away. But also, the particular individual, they can see the parts that they're good at and the parts that they're deficient in quite quickly by looking at a radar chart. You know, again, if I was to take that to a different industry, you know, where else might it be applicable? Like the film industry, like certain categories in terms of like how people might vote on it. Or if you were to take it to a restaurant in a simple case, and so like, I'll give you a certain amount of marks for your food, I'll give you a certain amount of marks for your drink, a certain amount of marks for your hosting. If you've got like, you know, 6 or 7 categories, a radar chart will be quite good for that in terms of showing how good any particular restaurant was. If they occupied more space, they would be better. So there's just a whole variety of these things. You don't have to use a radar chart to do that. You could have plotted that kind of scoring thing in a different way. For example, you might have plotted that in a bar chart. But the radar chart does a good job for it. So just another way of plotting your data. And finally, we go into what I call additional examples 02, because there's even more of these kind of things. We've got waterfall charts. I think that's one of the charts on the next page. Marimekko charts, force directed graphs. And again, I thought I'll pick 1 or 2 of these out of there. So the force directed one is in the next slide as well. Alluvial diagrams, hex bin plots, which I didn't pick, but I wanted to. They're quite nice because they're about hexagonal packing, and you can put things in squares, but if you wanted to get things closer together, circles don't work, but hexagons do work. You get this close hexagonal packing, and it's quite useful for plotting lots of types of data where you don't want to use just like square grids. Then there's choropleth maps, slope graphs, and I think I included the choropleth map as well in there. And then you've got candlestick charts finally, which was like one of our financial charts that we had before. So we'll take a look at some of these. And again, like when I go to the actual slides, like it's nearly like I am talking about them, but the reality is some of them tell you the information already straight off the bat. As in visually, you just see what they're telling their own story without needing a good chart. At least will tell its own story without needing like a too much of an interpretation beyond it. So here is our even more chart examples, and there's a waterfall chart. Again, I can think of the finance industry because I've seen it a lot in there, but it will go in the engineering industry, healthcare again, like a whole variety. Travel industry will use this a lot. But what it's good for is showing incremental changes across categories. In the financial world, one classic example, or something it's used for a lot, is if a company it gets its gross revenue, and that's the first chart on that's the first bar on the left hand side, and then in order to have got its gross revenue, it's had a cost. So you can see that category go down, and then it's had some more expenses. And then it's had the CEO salary and other things. And then it's had some additional income. And the final part of what's left, so it's quite nice and clear, descriptive for the investor, is what the net profit is of the company, or what's available for the potential of dividends. So it's quite a nice simplistic chart that might show a large company that's got lots of complicated bits. It can show kind of the breakdown of them into its componentary elements. The middle chart is what's called a force-directed chart, and this one again, it shows immediately, or what stands out is we've got big circles and little circles, and the big ones. What we have is always shown is a relationship between different entities. It's what pops out quite sort of obviously to us. And one of these, one great example is, and I've seen this for programming, is what is what are the most popular programming languages, and how they coexist, and where do they exist in the ecosystem. And you'll see, for example, the really popular languages like C++ and JavaScript and Python, they'll have these big circles, and then there'll be these other technologies around them, and there'll be lines connecting them. And if you were to plot that over the course of time, languages that were once small have become bigger, and other ones appear. So this chart is something that evolves over the course of time as well. And finally, the choropleth maps, which we didn't necessarily know the name of them, but you would have seen them in a lot of Wikipedia pages and other things, and they show variations quite often over a geographic area. And it could be a whole bunch of variations. It could be voting in a country. It could be rainfall, for example. So it could be the amount of crops produced, the GDP of that locality. So it could be a whole bunch of variations, whatever we wanted to pick and kind of measure that we felt was important. And this type of chart, like a heat map in some way, tells us something that has or tells us which areas or zones have more extreme versions of the measure that we're trying to effectively measure. So that's those charts. And then we move on. Additional example 03, and there were just so many more. I could put so many onto the slides without kind of over talking in terms of what was there. So again, these are just a few examples of the many different types of data visualizations that are available. But what we do know already is that without even too much creativity, there's already a lot that exists out there before we've even begun to put our fingers on the keyboards and kind of create new stuff. And along with that, there's new types and methods that are constantly being developed as technology and data analysis techniques evolve. And one example of that was the word cloud. We never really, although the concept of a word cloud, you could say 50 years ago or 100 years ago, it still existed in terms of a concept. We didn't have the data and tooling and the capability to need that, if that makes sense. But now we have that capability, and it become more and more common. So as we get these new data types, as our technology evolves, we're going to have other things as well. And we still want to keep up with that and make sure that we're along with it. And then the next slide, selecting the right type, which is quite, I'm going to say it's kind of fundamental. Selecting the right type of visualization depends on the specific data set and the message that we want to convey to our users. And sometimes we might want something in a simplistic format, and other times we want something in a different type of format. And you could sometimes argue like this one's better than that. Some, like if you put it out, the vote out to a community, the majority might like one thing and you might like another, and you sort of like go along with the majority vote because you're doing this to to show the infographic to someone else. And we've already seen many of these options in the previous slides. And you can imagine like some types of data, they do lend themselves very strongly to certain types, but other types of data, like you could pick and choose. So there's no right and wrong in this. Like some cases the things are a bit more black and white, but in other cases there's no right and wrong, and it's your opinion versus someone else, and it's what you want to try and extract out of that. So some considerations, here are a few things to consider in particular when selecting the appropriate visualization. The first thing that we do need to consider is the type of data that we've got, and there's a whole variety of types of data. Then it's the purpose of the visualization in terms of what we want to achieve with this. The next component is the audience themselves. So we need to consider who we're delivering this to. Are we delivering it to very young children? Are we delivering this to a whole bunch of professors? Are we delivering it to investors? Or is it something for ourselves? Or is it even like just a driver sitting in a car for a dashboard? And then after that, we need to look at the complexity of the data. And again, that sort of like feeds directly from the audience. We can get very, very complicated data, but that doesn't necessarily mean that we want to give very, very complicated visualizations to the audience. In many cases, they want something quite simplistic. And in other cases, they want something that contains a lot more complex data because they want to see the granularity of it. So an example of that might be for a fighter pilot, a whole truckload of information's coming in, like a vast amount of information is coming in, but the pilot doesn't have the, not that he's an intelligent, you've got a super intelligent person there, but the pilot will never be able to comprehend all of the information there. So a couple of simple visualizations to kind of like calibrate himself and his position and so forth would be on his heads-up display. And then after that is the number of variables, but again, that feeds into the complexity of the data in itself, because the more variables that you have, the higher the complexity of the data, and that feeds back into the audience. But again, we need to be careful about this because we don't want to oversimplify, and we don't want to transmit insufficient amount of data as well. And where's the case where we could transmit insufficient amount of data? Say you do have an audience, like a scientific community that wants to see all of the findings and wants to see all of the nuances, and then you go along and get this chart and plot like 3 red circles on it, and that's it, and don't show them anything else. And then like, what about all of the other granularity? We've just missed a whole host of information. Where do we see that? And you're like, well, I haven't got that to that in the visualization, and then it didn't help. So sometimes there's a craving for this extra information, and sometimes there's a craving for the simplicity, and we just got to understand where that is. And that does manifest itself in the complexity of the data and also the number of variables that are out there. So then the type of data, there's different types of data, such as numerical data, just purely numbers, X's and Y's and Z's and so forth. Then you've got categorical data, which like number of sheep, number of cars and so forth. Geographical data, they lend themselves to different types of visualizations. So some aren't suitable for certain things, and sometimes they are very suitable for other things. We saw, like, for example, categorical data, well, that fits into a bar chart quite nicely. It fits into a pie chart quite often quite nicely. Numerical data sometimes fits into a bar chart, might not fit into a pie chart, but would fit very well into a scatter plot or a 3-dimensional plot. So they lend themselves to these different types of visualizations. And our example of the bar chart is well suited to show the categorical data. And the scatter plot is better for showing the relationship between 2 numerical variables, where we wanted to see like some type of dispersion and a regression and so forth. Let's look at our three kind of like basic ones that we've spoken about and why that might be the case, or which might be suitable for each type. And I created these, I manufactured these examples, but like our scatter plot here, you could take two shares and they're like independent variables, and we kind of like want to measure the correlation between them. It wouldn't lend itself to plots, or it wouldn't have a meaning if we were to plot effectively like a line chart, and so like just join the dots up with a line chart, because they're uncorrelated data. So it's a bunch of random points on a chart, and they will form a picture for us in some way, and we will want to analyze and plot that visualization on the chart as well. You know, do we do a cubic fit? Do we do a squared fit? Do we do an exponential moving average for that type of data, or we do a regression that's quite often used, and sort of like standard deviations from the regression, and kind of like plot that in our chart, and that might be the way that we would use a scatter chart. But then moving on, we have like a line chart, and that just lends itself in some ways to like time series data, or data where the x-axis is an independent variable. So it doesn't have to necessarily be time series. It could be some other component. Quite often in physics, like you'll have a distance, and then you'll have another measure somewhere else, like a force or something, and the force is dependent on the distance. So that's an example where you still would need a line chart, and it wouldn't necessarily be a time series, but it does. Time series is a classic place where you would use a line chart. And in this example, I've just manufactured kind of like, and these aren't real temperature sort of things or whatever, but like you know, our temperature each year, each decade, we can sort of like, and there's like a randomly variable, which is temperature, and then a consistent variable. We measure something. We take this measurement once every 10 years, and do we see an object? Like, does our chart will show this relatively quickly, as opposed to our data, where we sort of like have to look at the top bit and the bottom bit and do an interpretation of numbers. We can see that 27.8 is bigger than 25. The line chart does the visual aspect of that in a much clearer way. And then if we had a spike somewhere in the middle, again, the line chart would show this more obviously than reading from a set of data. And finally, a bar chart. It keeps things very simple. It wouldn't suit itself to a scatter chart or a line chart, this type of data, although you could put those things on scatter charts and line charts. The reality is if you've got categorical data, so you would take like just a road in England or London somewhere, you take your random road and measure the number of vehicles that have passed over the course of an hour. So I've made this data up, but you might find that there's loads of cars and, you know, fewer vans and bikes, and so like make this measurement and say, like, you know, which type of user is the majority user on the road, and you might see that demographic change. And that again lends itself quite nicely, because it's categorical data, to a bar chart, and you might want to plot it out that way. And the results of that would be very clear, very simple, and that's it really. So you know, they're kind of like our three fundamental types, but we've got all of these other types behind them. And we look at the purpose of visualization. So the different types of visualizations are better suited for different purposes. For example, our line graph is well suited for showing trends over time, while a heat map is better for showing patterns in a large data set. And we have all of the other ones that we discussed earlier too. And here is our line graph, which is well suited to showing trends over time. And in this particular case, I kind of like pulled this out very quickly from Yahoo Finance, but it's a FTSE 100 price over the last 5 years. And underneath it, we've even for free got the volume. And we could quickly click on the different periods. So we can look at 1 day, 5 days, 6 months, and you'd get this line chart. And it may or may not be descriptive, but it tells you a certain amount of information quite quickly. It shows you some kind of volatility, which is roughly between 6,000 and 8,000 in terms of like what you might expect to like make or lose, or for the purpose of calibrating your investment. And it shows that it's kind of like it's finally finish its 5-year period somewhere towards the upper level. And we can sort of like garnish that relatively quickly just from looking at this simplistic chart, and you can sort of flick through many of them quite quickly and come along with decisions for that in terms of visual decisions. Then we go to another type, which is a heat map. And again, I've sort of like taken this from a similar sort of sample set, but it comes around in a different type of way. And the heat map is better for showing patterns in a large data set. And this particular heat map doesn't have like bigger squares for for larger companies with bigger market capitals. It's much more simplistic, but what it does do quite efficiently, because you couldn't do this with a bar chart because you just couldn't fit all of the components, like 100 components across the x-axis, is it lets you put 100 components in a 10 by 10 grid quite nicely on the screen, and it lets you order them and put the highest ones at the top and the lowest ones at the bottom, and sort of like colorize them, and the ones that haven't moved kind of like mark them white. So we get this very descriptive thing. Our eyes, we can make very fast decisions quite quickly or ask questions. Is there something happening as a company reported or something like that that's moved in a certain way? And quite often what you'll get with these types of things is maybe the entire market's up, so it's all greens or blues. Maybe the entire market's all down, so it's all reds. Or sometimes there's some particular news or good news in a specific sector, and a whole bunch of home builders or something else will show greens, whereas a whole bunch of other ones will in a different sector might show something else. So, and that's a snapshot on a particular day. So it's quite a useful chart to have. And then we move on to the audience. The intended audience for the visualization should also be considered, and it's actually quite a massive consideration. Some visualizations may be more easily understood by a general audience, while others might be more appropriate for experts in a specific field. And if we go to the extremities, you can get a class full of children, and you've got to deliver them. If you were to deliver them something that had loads of words and like moving parts and lines and so forth, they wouldn't have a clue what was going on. But if you were to sort of like put a couple of nice pictures and a duck and a few simple things, they'd be able to interpret something relatively simple. Then we move to sort of like the school sort of era, and what they might do at that point, or you might be looking at investors, and they want to see data in a different way. They want to see a bit more data potentially, but they might want to see it targeted in sort of like a clean and well delivered format. And then finally, like you move on to like more technical people, where and showing them this simple chart now longer doesn't help them, because they needed to see the granularity and they were sort of like craving more information. And you might show them a couple of simple charts, but they want to delve into the more complicated of the visualizations. So we move on to the complexity of the data. And if the data set is large and complex, a simpler visualization may be more effective in communicating the key insights. So whilst a more complex visualization in some cases may be needed to show all of the details. And we just look at like our left-hand side of data. And again, I kind of like hand manufactured this, but like if you were taking a whole bunch of share prices, and like you could consider it to be complex data. And if you imagine that set was much larger, like millions of data points over time, it's how do we get this out, not just to other people, but to ourselves for the purpose of understanding? Can we simplify the data in some way without losing too much of the information, and retaining the key points, like a sampling perspective. Whereas if we look at the right hand side, we've got like some simple data, some categorical data. We don't need to do very much work on it, and we don't want to overcomplicate it. We just want to deliver something quite simple, like a pie chart or a bar chart. So that's very much a consideration for us. And then we go into the number of variables. That's sort of like related to the previous slide, but the number of variables that you're trying to show in the visualization should also be considered. Some visualizations, like a scatter plot, are better suited for showing multiple variables at once, while others, like a bar chart, are better for showing one variable at a time. And finally, in this particular little section, ultimately, the key to selecting the right type of visualization is to experiment with the different types and see which ones best communicate the message and the message that we want to convey to the audience. And then we go along with our best practices. So here's a few best practices for selecting the right type of visualization to communicate your message. And the first thing is to start with the message itself. Then we want to try to keep it simple. We want to use appropriate scales and axes. We want to use appropriate encoding. So we'll delve into what that actually means. Then we want to be aware of cognitive biases. So we want to keep the integrity of our data set. That's what we're talking about there. We want to test with our audience. So see if the audience actually appreciates it and understands what we've got. Then we want to, because we have this available, you're not restricted to one chart. You don't have to do just like one thing. You can do multiple visualizations to communicate the results in a better way. And finally, keep it interactive. Well, that gives you the feedback that you need. So a whole bunch of things in the best practices. And we start with a message. Before selecting a visualization, identify the key message or insight that you want to convey. And this will help guide your choice. And kind of like I just put two things on, we see one thing on the left-hand side and a little picture on the right-hand side. But the left-hand side, like behind the money bag, in front of the money bag and behind the coins, we see this red line. And that's like a very simplistic visualization, but the reality is what is it showing us? Ultimately, that the price is going up. Someone's trying to convey the message that something's going up, you're going to make profits. They've drawn this on purpose to draw in the investors, but they've also, it's somewhere in the middle, have shown a downward line. And that's showing like maybe you have to sort of like be patient and be willing to accept losses in order to make profits. So a very simplistic, I took the most simplistic one actually and pictorial one, but the reality is that that comes in the more complicated formats. And then on the right hand side, you're not displaying things, you're displaying things to a different type of audience, and you want this more complicated type of chart that you're going to show. So you know, and it's to a far more complicated audience, and you've got this visualization that sort of like needs to account for a whole host of other factors. And this chart is like harder to read, but for the audience that it's delivered for, it's pretty standard for them. Now, keep it simple. Simple visualizations are often more effective in communicating a message than complex ones. Avoid using too many colors, labels, or other elements that can make the visualization cluttered and difficult to interpret. So I go along, and on the left-hand side, we've got something very simplistic, and you can sort of like take a look at it. And at the top, it says type of movie. And straight away, like visually to our eye, if you just sort of like ask the movie director, like which movie do you want to produce next, he might turn around and say a romance one, and you say why, and he says, well, it's a red sector, and the red is more than anyone else, you know, and that would be a great decision. And which one would you least want to produce? And it's a drama one, and again, why? Because that occupies only 5% of the space. So I have several times or 6 times more chance of people watching my romance film than if I was to create a drama. So and they can use that data to drive their decisions in the right way. So an unskewed, just true representation of what people want to see. And if they were in the wrong sector, they can then move into the right sector. Now, on the other hand, we've got this complex form, which is on the right-hand side, and that was pretty much like, you know, one of the previous charts we saw before, where like you might want to see an entire breakdown, and it might be applicable to be complex, but in some cases it might be overcomplicated and too scary, and people move away because it's not what they were looking for. You could look at that chart, that complicated chart, and go like, I just want to see a simple pie chart with 4 colors. I just want to see the red, the blue, the green, and the yellow, and I don't care about all of the nuances, and there's too much labeling and so forth on it. But another type of audience might want to say, well, I want to drill into the granularity of that, and I want to sort of like see how the breakdown is made up and so forth. So you've got to understand your audience when delivering it, you know, which one of the two is correct. It literally just depends on the audience that it's going to. Then we want to make sure that we use appropriate scales and axes. Maybe that's something that we've learned early on. but the scales and axes of your visualizations need to be appropriate for the data and the message that you're trying to convey. For example, and this is just a pretty simple example, if you're showing a large range of data, you might need to use a log scale. Otherwise, you'd kind of like distort the data. So that's pretty much a straightforward example. Does the straight line on that chart, if there was more data contained within the lower components where it says 100 on there at the lower scale, you wouldn't be able to see that, whereas it would show more clearly on a log scale. So just something to be aware of. And then use appropriate encoding. So they use the right type of encoding for the data. For example, use perspective data length or angle for ordinal data, and then use color or shapes for categorical data. So there's no point if you've got categorical data of drawing all of your bars in red. It might help to put your bars in different colors, and that's just a very simple example. And also we need to be careful, like, if we're doing like measurements on length, like in terms of distances that someone has traveled, if they're doing car journeys, which could be tens to hundreds of miles, do you want to amalgamate that data with journeys that they do on foot, which could be 0 to 10 miles? The larger scale, so you might want to break that up into two components of journeys made by foot and journeys made in a vehicle. So just that type of thing to bear in mind. And then we come on to the cognitive biases. So people can perceive visual information differently. We need to be aware of cognitive biases, like the Weber-Fencher law and the principle of similarity and the Gestalt principles, and just try to avoid them when designing our data visualization. And this is something that's incumbent upon all of us. But one of the things that we have, and there was many formats of this visualization, so I took the cartoon version, but we've got the objective facts on the far left-hand side, and then we've got our confirmation biases, or what we believe to be true, and that clouds the intermediary part, which is labeled what you see. And if we can remove our confirmation biases and just stick to the objective facts, then what we're seeing is a larger portion of the data, and we can make better data-driven decisions. So where we've put political biases, and that's where this kind of thing does fall in, where we've put some sort of political biases or skewed our data or wanted to tell a story that wasn't particularly true, we've then moved away from the objective facts, and that's not part, that's against the principle of what we want to try to do for the purpose of data visualization. And there's just some examples of cognitive biases. I'm not sure that I'll have time to go into too many of them, but we'll go into some. But there's 15 of them here, just in this little infographic, which influence the way we think. Group thinks at the top, but then you can got the bandwagon effect as well, and the status quo bias, and those types of biases. They kind of talk about similar sorts of things where effectively you're following some sort of crowd. Then we've got our own self-beliefs, and we've got some sort of courtesy bias. We've got one called anchoring effect, and that's where our visual data might show us quite clearly that a data point is an outlier. You were going to purchase the price of a property, and if you had the visual data, you could plot out all of the property prices, and the estate agent that's selling you the property is telling you that the property is good value, but it's blindingly obvious if you were to look at the whole data set that it's poor value, but they've anchored you to a level. And without the clear visualization, so they might have skewed the data as well. Without that clear visualization of the data, you are likely to make a poor decision buying a house at an overinflated price from them, but inadvertently without realizing that. Then there's other things as well. For example, the ostrich effect, which is more pertinent, but it's kind of we're just literally eliminating large portions of the data by sticking our head in the ground. So we don't realize that it's there. And then there's other skews that we have, like the gambler's fallacy and so forth, which are quite interesting ones. So when we've got these independent variables, we feel like they're dependent. So if I roll a 6 20 times in a row when I'm in a casino, what's the chances of rolling a 6 the next time? because I've rolled it so many times, it can never happen, and therefore the probability is much lower, much greater that I'll roll a different number, and that might not actually be true. It might be the complete opposite. You might even be rolling a loaded dice. So there's those types of things, and we may or may not be able to show them in our visualizations. We move on and we want to test with our audience. This is going to be an important factor before finalizing your visualizations. You need to test it with a sample of your intended audience to ensure that it effectively communicates your message. So you put out your infographic, and if a whole bunch of people go, what the hell is that? I don't understand what you've just spoken about. Then obviously you need to make it more simplistic. And on the other hand, if you've put out your infographic or whatever you've done in terms of your visualization, and somebody says, well, what about this and what about that? You're missing all of these points. You've missed the delivery to your audience. So we've got to make sure that we get that right. And that's understanding our audience and the feedback loop. Sometimes when we use multiple visualizations, it can be more effective than using a single one. So go ahead and use multiple visualizations. Maybe you haven't been able to communicate something in some way, or somebody doesn't see something on your first visualization, but it's much more apparent to them on a second one. So put 3 visualizations out there if it helps, of course. And for example, using a bar chart to show the overall trends and a scatter plot to show the relationship between 2 variables can just be more effective than picking just one of them to show it. So 2 is better than 1 in many cases. And if we want to keep it interactive, interactive visualizations allow the user to explore the data, filter through it, and compare different scenarios. So this can help to find patterns and insights that would be overlooked in a static visualization. Here's one of the principles that we talked about earlier, the Gestalt principles, and this particular one's the law of continuity, which shows that the human eye will tend to follow this smoothest path when viewing lines, regardless of how the lines were actually drawn. And here we can see we've got this red line, or the red dots, and that comprises of a line and a curve, and we've got the grey line, and that comprises of a line and a curve. But if we were to plot them all in the same color, so if we were to use monochrome, you wouldn't get that. Our human eye would see a horizontal line, and then it would see a curve. So we just got to be careful about how we display data so that we don't put a bias in it, and that it comes the right way and it's showing us what we want to actually be showing. And again, here's another example. This is closure. This is things that our brain does. And I'm not going to show too many more of them, although I'd like to, but our brain fills in the missing parts of the design. And here's a the World Wildlife Foundation image. And I tell you it's an image of a panda, but your brain's already, although there's no part of that, that's actually the drawing of a panda. Our brain has filled that in for us. And our visualizations will to some extent have the same effect. And we look at proximity, which refers to how close elements are to one another. And if we look, our brain interprets the image on the right as 3 distinct groups, whereas the image, our brain sees that as one group. Now, the reality is that the image on the right might have actually been one group, but our brain automatically does something different with that. And there's a whole variety. There's actually many more examples of that kind of thing, and you have a tree diagram, but our brain does all kinds of odd things, and I don't know if you can see this in this image, but you've on the left hand side where you've got what effectively is a tree, but inside of that, you've got a gorilla and a tiger that are sort of imposed implicitly in it. But the other important factor is color. Color is massively important. It does help, and we can determine the color of the shapes much better than if it was just monochromatic. So just principles to be aware of. And then how to interpret data. Interpreting and creating useful and insightful data visualizations involves several steps. We need to clean and prepare the data first. We need to understand our data. We need to then choose the right type of visualization. We then need to set about creating the visualization. That can often be quite difficult to do, by the way. And then we need to be able to interpret the visualization that we've now created. And finally, from that interpretation, we need to be able to communicate that message to our audience in in the way that they're expecting it, whether that's simplistic or more complicated. So in terms of cleaning and preparation of the data, before creating any visualization, it's going to be important to clean and prepare the data. This includes checking for missing values and outliers and looking for errors, and then transforming or aggregating any data where it's necessary to do so. And I think we're going to see that on the next slide. Yes, we do. And this is something that I manufactured myself. I've come across this like dozens of times, hundreds of times, in my cleaning data example. And finding the null data and the blanks is quite obvious visually to the eye. And the computers do this tremendously well. But finding that outlier is potentially less obvious, at least to our eye. If that number, that random number in the circle, instead of being 958 was 1058, it'd be a bit more obvious because it would stand out because it'd be an extra column there. But we need some sort of algorithm potentially to do that. We want to correct our bad data with averages or interpolation. So how do we correct that 958? Do we just interpolate between the point in front of it and the point after it and say it's the middle value or some interpolation of that? Do we take an average of the whole data set and assign it to that value? Do we take some kind of exponential moving average leading up to that data and use that as a value? Effectively, what do we do with that? And that's going to be forms a massive part of it. And also, if that error, instead of being 958, if that number, because that's probably clearly an outlier, if it was like 150, do we measure that as an outlier, or is it actually real data? So that represents some form of volatility. And so like our decision-making process is quite often, there's a bit of a finger in the air in terms of what it is, but like the visual process will certainly help draw our eye towards these things that are at least outstanding, whether they're errors or whether they're real, and we can go and investigate them. So understanding the data, once data is cleaned and prepared, it's important to understand the distribution, the patterns, and the relationships that lie within the data. This can be done by creating summary statistics, just in our simple diagram down below, so something like the mean and the median and the standard deviation, or by creating some simple visualization such as a histogram or a scatter plot. And here I've just taken something, and this is quite a common thing. So it's like have a normal distribution or a log normal distribution, and we'll have some kind of mean, and we'll have some kind of dispersion from that mean, which we might refer to as a standard deviation. And we go from there with our purpose of understanding the data. And the right type of data visualization based on the message that we want to convey and the type of data, we choose an appropriate type of visualization. For example, a line graph is well suited to showing trends over time, while a scatter plot is better for showing the relationship between two numerical values. And in this little picture down at the bottom, I kind of like show these scatter plots where you've got this positive correlation in the first plot on the left-hand side. Then you've got like a negative correlation on the right-hand side, and finally you've got one that's got no correlation at all, as in the plots are sort of like uniformly distributed, and each one of these is telling us a different set of information, and it's quite clear what it's showing us as well. And this is actually finally we get to some real data that I've created myself. And it just depends on the individual and who you're delivering this to. And I use something called, I use a package in Python called Seaborn, which lives on top of Matplotlib. And I've kind of like plotting different cryptocurrency prices, so the different assets. And I fitted them to a quadratic, but is a quadratic the right fit? You could ask straight away. Initially, it's an okay fit. And did I want to put all of these things into one chart, or did I want to split it out into 6, or did I even want to do a three-dimensional chart? And it's sort of like I use a Seaborn pack, and it prints something out and gives a display that's used. Was myself and not someone else, but someone else might look at that and go, that doesn't tell me anything and it's not intuitive. So you've got to know who you're delivering to. And we want to use, for the purpose of creating the visualization, we want to use appropriate scales and axis and encoding to create this visualization. We want to avoid using too many colors or labels or other elements that can make the visualization cluttered or difficult to interpret. So it's just got to be at that right level for each individual user. And here's an example of visualization. And again, this it's what I call maybe a simple and an informative look, but this is something on a dashboard that I built for myself. You know, looking at the percentage of assets held within a certain holding, and straight away you can see the percentages. But even if you didn't have the percentages, you sort of like see the assets and the percentages, and that's great for something like a dashboard where you want to just sort of like look at it, click your fingers and sort of like draw some immediate conclusions as to like your asset dispersion, and if you were happy with that, and you didn't want to get into the granularity or the detail of how these sort of like occurred and so forth. So this is a very simple and informative look. And then we want to interpret our visualization. So once the visualization is created, we want to interpret the insights and the patterns in the data. We want to look for trends, we want to look for patterns, and we want also, importantly, to look for the outliers and use these insights to literally make data-driven decisions. And again, go back to that same diagram as before, but here it's kind of like a simple and informative look. And what did I draw from that? Well, there's too many pound sterling in there, and potentially not enough Bitcoin, because that's the way that I wanted that aligned. But you might have the same thing, like simply on a dashboard of a car for your speedometer. You might want just one red mark telling you where the speed limit is, and all of the rest of the dashboard and so forth. So just things where we want our displays to give us the result quickly. And then we want to be able to communicate the message. So finally, communicating the message and insights clearly to the intended audience. We want to make sure the visualization is easy to understand and includes all of the appropriate labels and titles and captions or whatever is needed, but also at that same point in time, not too much of that. An example of communication again, here's another one that was on the same dashboard. It's very easy to understand. It's the bar chart. It was again drawn in Seaborn. It could have been drawn in Matplotlib, but straight away it shows that one particular thing, you know, too much of this particular asset is locked away for the purpose of trading, and it's quite obvious from that chart. And you can react on it very fast if you wanted to. But the point is that it just stands out like a sore thumb relatively quickly. And then finally, in our summary on interpreting our interpretation, creating useful and insightful visualizations involves not only good technical skills, but also the understanding of the data, and that's quite important, and the context of the audience and the ability to communicate that to the audience effectively. You might just be communicating it to yourself. You might be communicating it to a whole bunch of other people. It's important to keep in mind that data visualization is not just about data looking pretty. It's about, and I put this kind of like highlighted in a way, it's about finding insights. It's about answering questions, and ultimately, and kind of like most importantly in a way, it's about making data-driven decisions, because that's without biases, because that's going to be the key to good results. Now, going on to that, we need to look at data cleaning. And this is quite important. So data cleaning and preparation is an essential step in the process of data analysis and visualization. It's important for several reasons, and some of them might be quite obvious, but it ensures the accuracy and reliability of the data. Otherwise, you just have a whole bunch of spurious data going into our model that won't be very good. It improves the efficiency of the analysis. It avoids errors and biases, which is, you know, again, we don't want to be skewing our data in some way that's against us, or reduces the ability of our model to come out with a final conclusion. It improves the quality of the visualization, and it makes data more usable for what we want to do. And finally, it helps us integrate our data into all of the other systems. And we're going to be passing, like in many cases, we pass through multiple systems, and we just want that to be homogenized in some way. If we look at accuracy and reliability, and cleaning and preparation, preparing the data ensures that it is accurate, at least to the best that we can do, and that it's reliable and that it's consistent. And that is important for making data-driven decisions and drawing the accurate conclusions that we need from our data. So let's just go on to here's the question. For the purpose of efficiency of analysis, cleaning and preparing the data beforehand is going to allow for more efficient analysis and a modeling process. And this can save a lot of time and effort in the long run. So whilst we're going to have to do a lot of hard work initially, and we take, like, if you look on the left-hand side of this, you've got this, like, I've called it world data. It's unstructured data, that we've pulled out of the real world. And there's a lot of effort into kind of like getting, like, formatting it into some sort of structured data. But then we're going to get the benefits afterwards, because we're going to be able to pass this into some sort of efficient analysis process. And in some way, whatever it might be, draw some kind of conclusions or be able to make these much better data-driven decisions. And we want to avoid the error and biases, and data cleaning and preparation can help to avoid these errors and biases in the data, which can lead to inaccurate conclusions and predictions. And we've sort of like seen this box plot before, but on this particular box plot, I wanted to sort of like highlight the extremities where the little dots that lie outside of our maximum and minimum. There are outliers and they skew the data. And if we have loads of skewed data just on one side, that's going to create a problem with our data set. But also, it might just be purely bad data. For example, like if I've got the exam results of 10,000 students, and for some reason I see exams go between 0 and 100%, and I see something at like 110%, I have to ask myself the question, or you have to ask the question, was there an error in the paper or an error in the marking or something that's produced 110? Because we know that our maximum result is 100. And likewise, if we saw a negative number somewhere, was there negative marking involved? In which case that's fine. But if there's no negative marking, our lower bound is 0. How do we get a negative number? That's an outlier, and it's going to skew our data. And it might even, in many cases, like highlight an error in the system that we've got. And the data visualization will do that very quickly. We want to remove biases in other ways as well. And quite often a keyword is to normalize the data. And it's very much a key thing in finance. We want to normalize our data to remove bias. Here we see like, if you know anything about bonds, like we see the German 10-year bond, and we sort of like see the yield going up. And if we were to look at it in isolation without looking at all of the countries around it, we might think that this is something that's specific to a specific country. But then if we start plotting other countries around it, and I've just put France in here, but we could have put in the entire European Union, would have seen that this is actually much more global data that's kind of like driven across all countries, and it's not sort of like led by one particular country in some way. And we might do things like adjust for inflation and so forth. So we can remove our biases in a whole bunch of different ways. And again, our techniques for doing this are just going to depend on what we want to do. It's like if we were looking at like cosmic background radiation in science, and we got some kind of signal, we want to ask ourselves, is that a true signal? And we sort of like want to remove what's called the white noise away from that. So again, this isn't like a financial thing or a healthcare thing or any of the other specific industries. This is industry wide. We want to kind of like scrape the biases out of our data. Then we look at the quality of the visualization, and a clean and well-prepared data set leads to more meaningful and accurate visualization. And I quite like this one. This can greatly enhance the ability to communicate insights and patterns in the data. And here we have something which is the KNN classification, which is the case nearest neighbor. And if I was to ask you, put another point somewhere on that chart and say, is it a blue triangle, a red circle, or a green square? Even though like you didn't know which one it was, you could sort of like, given this well organized and categorical data, you might be able to say which one it probably is because it lies within that data set. And if you had something lying somewhere in between all three data sets, you could do this technique known as case nearest neighbor, which is find the nearest ones, and then say, well, there's quite a high degree of probability that it belongs to that data set. And if we look at that point in the middle, it's saying there's a small chance that it's a green, but much more of a chance it's a red, and probably not very much chance that it's a blue. So we're going to infer that that's probably a red, and that's already kind of like the beginnings of bordering on to like neural networks and artificial intelligence, although it's just a technique that we use. And then it just makes our data more usable. So cleaning and preparing the data makes it more usable for other purposes outside of that. It can be used for other analysis, modeling or shared with other teams or stakeholders. So we take this data and then we pass it somewhere and we don't know where it's going. And but in this particular case, it's going into a prediction model. So whilst we've just done this cleaning and other stuff and we don't know what's happening, we've got this nice infographic as well that we can see here. It's now telling us, kind of like dictating what model we might use. And in this particular case, you know, we'll pick a KNN model, but we might have used a different model for a different type of data. And finally, it enables integration. So the data cleaning and preparation is also going to be important for integrating data from multiple data sources. It ensures that the data from the different sources can be combined and used together in a consistent and meaningful way. And that leads us on to this nice example, which is integrating data from multiple sources. The multiple sources are our clouds from the world. We're taking our world data, which we say is unstructured data. And in some way, we want to get the homogeneous and heterogeneous, so our nice structured data out of our unstructured data, and to like pass that into a table so that we can use it on other things. And finally, just as a summary of data cleaning, overall, data cleaning and preparation is going to be an important step in the data analysis process that can greatly improve the quality and accuracy and usefulness of our data for all the reasons we've discussed earlier. It's going to be important to take time to properly clean data and prepare the data before, and that's quite important, maybe I should have highlighted in yellow, but before creating the visualizations or drawing conclusions, because if we didn't, we'd get poor visualizations and we certainly get poor conclusions. So we need to make sure that our cleaning process is there. And finally, like the last topic, creating meaningful narratives. Creating meaningful narratives with data visualization is going to involve several steps, and I'll go through this quite quickly so we can get towards the end. But we want to identify a key message. We want to select the appropriate visualization. We know some of these already from our earlier discussions. We know that we need to clean and prepare the data. We need to create a visualization, and that's for the purpose of telling our story. And then we need to use our storytelling techniques. We're going to possibly use these multiple visualizations, and then we're going to test this on our audience. And once we've done all of that, we're going to iterate over those steps to keep improving. So meaningful narratives, creating meaningful narratives with data visualizations requires not only technical skills, but also some creativity on your part, some storytelling skills, but hopefully true stories and an understanding of the audience. It's important to keep in mind that the goal is not only to create good looking visualizations, but also to convey the insights and inform decisions about engaging in a meaningful way. And I think that comes to the end of our presentation. I know I've left, at least I've left 20 minutes this time, so it's enough for a Q&A session. I know that we've gone through a lot and it's like been varied, but I guess if, do I hand back, or if anyone wants to ask any questions and answers? I saw that one popped up. Does the host want to take over for questions and answers, or shall I just go and answer any questions?
Yeah, I can. So it says, Darren, good webinar first. And this is a question from Eric.
Yeah.
He says, which one do you recommend in Python, Matplotlib or versus Seaborn versus any other?
I mean, the realities on that one, it just depends what you want to do and your ultimate objectives. But like matplotlib in the Python ecosystem lives somewhere, which is it's kind of like your first go-to way for plotting charts, and actually it does like a humongous amount straight off the bat. But it's kind of like, it's not the only package. It's like a whole ton of other packages. And when I did the Python course actually with you guys, there was a little bit at the end, which was Seaborn, that came after matplotlib. And I kind of like used Seaborn before, but not that much. And I had to delve into it a lot more. And Seaborn lives on top of matplotlib. So it does a whole bunch more. And whilst you can do all of that stuff manually in matplotlib and sort of like that integrated with the pandas data frame quite nicely, Seaborn did that kind of like in a better or more complete way. But then it lost some of the or it gives you a lot of stuff out of the box, and it sort of like takes some control away from you, but you might argue in a good way. So it creates this quite comprehensive package quite quickly for you to give you a narrative. But the reality is, so I've used matplotlib, I've used Seaborn, but then there's other packages as well, like Plotly and so forth, where you want to push these things to the web. I push mine in a matplotlib and Seaborn, but they're static. You might want like a more dynamic type of package. So again, they will no longer be sufficient, and you'll move into another package like Plotly. And why do I say that? It's just because I see it quite a bit on Stack Overflow. Actually, people asking those questions, and I answered the question in a way that was sort of like a static answer, and gets downvoted, and it's kind of like that's not what the user wanted to do. The user wanted to use it in a dynamic way, and these other packages were deficient in doing that. So that's what that did.
Thank you.
That's okay.
You can post any more questions here. We still have time. I see one more question here which says, how can you visualize more than 3 dimensions in a single chart?
Okay. One thing that you can do, like if you're going to, it'll become obvious when I've said it, but like one thing that you want to do, but it depends on how many dimensions that you want to get. But if you want to say, for example, go into the 4th dimension on a 3D chart, quite often the 4th dimension is time. So one of the things to do is actually make the components move. Now you've actually gone to 4 dimensions. So particles in a box, or like, if you wanted to, like, it's something that I did back in university, but like we could only do it in 2 dimensions. But if you wanted to collide 2 galaxies and see sort of like the resultant, what happened to the stars afterwards, like where they moved, or you wanted to like look at gravitational forces, you actually want to look at that in 3 dimensions, 3 of space and then 1 of time. So that's just like a sort of like a simplistic answer. But in finance, you're quite often looking at multi-dimensions, and these dimensions aren't like what we perceive to be like the real physical dimensions. But then in some cases, you can plot multiple things on the same chart. But the reality is you might actually at that point break it up from thereafter, because you're potentially showing more information than the human can comprehend, although you can sort of like comprehend it conceptually, or in that 3 dimensions. Can you go to like a 5th and 6th dimension? And the answer is not really. And the reality is even like if I was to take that scatter plot and sort of like just plot a 3-dimensional version of it and then point to one of those points and say, where is it on the 2D plane, without extra components or like vertical lines and horizontal lines showing where it like crosses with the plane, you wouldn't be able to see that. So you can, to an extent, you can certainly like put moving animation into it. That definitely gets you an extra dimension kind of like for free, and that's an advantage. But then afterwards, you have to start being creative.
Thank you. I hope this helps the candidate for this. I see one more question here. It says, what are the characteristics of a good data model?
I'm wondering what capacity that's in, but first of all, obviously getting information in. But this isn't just like a data scientific or data visualization model, but it's rubbish in is rubbish out. So cleaning is like a very important component. Knowing how to clean, like where the outliers are, So that's the first kind of like that's the first component of it before you've even started with the visualization. But the reality is it's got to give you what you wanted to get. And when I say that, it's got to, like, the visualization, consider it as the middle component, just after like you've done your data crunching and your data cleaning. So we push them to the side now. It's got to give you, at least for the human being, not for an algo, something that enables us to make our, what we classify as a data-driven decision very quickly. And that could be something very simplistic. So like when I did, like, you know, the pie chart of the assets I had, it could just be something like that, or a bar chart. So it isn't like one rule, it's multiple. It depends on what you want to get for your data, and that's multifaceted, because you might want to get something a bit more complicated. So it's an open answer. It's an open answer.
Okay, thank you. Now, I don't see any more questions.
Okay.
Okay, guys, if you come across any more questions, you have any doubts, you can always reach us at info@careerera.com. So I think that will be all for today. Thank you, Darren, for such great insights. Thank you.
Volume come.
Hello.
Hi, I'm back.
Yeah, I said thank you very much for those insights. It was great listening to you. And for any further queries, candidates can reach us at info@careerera.com. And that was all for today. Thank you.
Okay, thank you very much, everyone, for taking the time to listen to it. And I hope you all drew some useful information. You're welcome to get in touch directly via, you know, the course and the company. You're welcome to message me directly as well. So thank you very much too.